All right, this video is going to cover sinusoidal models. I'm not going to sugarcoat it. This is going to be difficult. The reason is because you're going to first have to draw an accurate graph. Then from that graph, you're going to have to make an equation. Then from that equation, you're going to have to solve. So let me show you what I mean. First of all, you need to know that time is generally your x-axis, which means whatever else you're dealing with, like height, for example, would be your y-axis. And you also want to look for maximum and minimums. So like this first example, I don't even start seeing anything until I see it takes you 3 seconds to reach the top, 43 feet above the ground. That means at 3 seconds, I'm at the top, 43 feet above the ground. And the wheel makes one complete rotation every 8 seconds. So that means 8 seconds later, 3 plus 8 is 11. I'll be back at the same spot. This is the period. The period is 8 seconds. This is a very, very big piece of information. Now, lastly, they'll tell me the diameter of the wheel is 40 feet. So like imagine this wheel. This whole diameter is 40 feet. So if I'm at the top up here at 43, that means the bottom is going to be 3 feet above the ground, which means your midline is 23. It's just a smack dab in the middle of those. So here's the midline. Halfway through the period, so 7, I'm going to hit the bottom, and my graph would look something like this. Then it, of course, would repeat. All right, so there's my accurate picture of this so far. Now, the next thing that I have to do is make an equation out of it. So remember, A is your amplitude. The amplitude here is the distance off the midline. So my amplitude is 20. B is kind of similar with the period. You have to take period is 2 pi over B, and you know the period is 8. So it's like this. 8 equals 2 pi divided by B. Make it over 1, cross multiply. You'll get 2 pi equals 8B. So therefore B, after you reduce, is pi over 4. I just used period equals 2 pi over B to get that. C is your start location, 3. So it needs to say x minus 3. And then D is your midline. C was 3. D is your midline, which was 23. Once you have all this information, write your equation. The equation would look like this. F of x equals, my amplitude was 20. This is a positive cosine function. B was pi over 4. The start was 3. And my midline was 23. This is basically your goal, because if you can get that, well, now you're just plugging in stuff. So like if they say t equals 6, t is time. Remember, time was our x. So we're just plugging this in for the letter x. And then you just run it through a calculator. You would get 8.857. So for all of these, that's what you're going to do. That's how I'm going to get these answers. You just plug them in. Then they'll generally ask you kind of a backwards one where they give you the y value. See, like this is height. Height was here on the y. So they're giving me a y value of 18. This is where you would plug it in here. So it looks like this. And you have to go solve this for the letter x. So you would subtract 23, you would divide by 20, then you would need a calculator because you're gonna have to run arc cos. So here, I'll just write it out real quick. You would subtract 23, so now it's -5. You would divide by 20, so now it's -0.25 or -1/4. You then run arc cosine on both sides because it's going to cancel the cosine on the right side. So when you do this, you'll get like 1.82 equals pi over 4 x minus 3. Now you would times by 4 over pi to cancel this. So you end up with, let's see, that's 2.32. Then you just add 3. So that's how I'm getting this answer. You have to be able to work these out and solve for x values. So this is seconds. All right, so that's essentially what you're doing on all of these. Let's look at another. The steamboat problem. So Mark Twain is watching a wheel go round and round. So the height is going up and down across time. That's a sinusoidal. So I'm going to need to draw this accurately first. Now, the first thing that I see is when his stopwatch read 4 seconds, the point was at its highest. So 4 seconds in, he's at the highest. And that's 16 feet above the water's surface. The diameter of the wheel is 18 feet. That means the lowest it's going to go is -2, 2 feet underwater. It completes 1 revolution every 10 seconds. So 10 seconds after 4 seconds, so 14 seconds, it's going to be back at the highest. Split the difference there, 9. That's when it's going to be at the lowest. So it looks something like this. And then it would, of course, repeat. All right, so there's my graph. Now you have to go get all the A, B, C, D. So the midline here would be 7. Up 9, down 9. So let's just go ahead and look at it. Your amplitude is 9. The B value, this is the tricky part. You know the period is 2 pi over B, right? Well, the period they told you is 10 seconds. Make it 10 over 1, cross multiply. Divide by 10 and reduce, you get pi over 5. It's my B value. The start was 4. My midline is 7. So now I know ABCD. I can write an equation. So there's the equation that I'm going to be using to solve these. So for like these, they're just giving you a time. So since they're just giving you time, you can just plug these in for the letter X to get those answers. So this one's going to be 14.281. The second one's going to be 4.218. I shouldn't have to explain in great detail how to get those. You're literally just plugging in a 5 for the letter X and then punching it through the calculator. All right, now this part's going to be tricky. Before I should show you how to do this, I need you to realize something. Realize this. If you have this curve, right? Say the max is at 5. And you know that you have a value here Let's say this had a y value of 6. And you want the y value for when it's 4. So you know this. And you know it happens at 5.5 seconds, right? 5.5. I need you to understand that there's a dot on the other side of this hill, the same distance away at that same height, 4. So this green dot would be the same distance. If this distance is 0.5, then this distance has to be 0.5, 4.5. I'm going to be using this in a second, so I hope you understood that. So here we go. Basically, what's the first positive value of time at which the point was at the water's surface? So we are looking basically right here. So a y value of 0. So you solve this equation for a y value of 0. If you do that, you get 7.92. Now, I need you to realize this green dot, it may not be your answer. We might have, before our 4, we might have hit the water's surface on a positive amount of time. So what you do is you say this distance right here to the bottom of that hill, 9, is 9 minus, this was 7.92 right here. So you do 9 minus 7.92. You get 1.08. That's this green distance. So what that means is there's another bottom of the hill right here. Okay, and the period was 10 seconds, so that's at -1, an x value of -1, which means this green section is the same thing as this green section. You add it onto the -1, and we had a spot at 0 at 0.08. 0.08, x value of 0.08. So my answer is not 7.92 because they said the first positive value. The first positive value was 0.08 seconds. Again, we knew it hit right here. We knew this distance was 1.08 to the bottom of the hill, which means then if you go back a period and you got the bottom of the hill, this distance is going to be the same as this distance. And as long as your answer, if you add that 1.08 to the bottom of the hill, as long as that value is positive, it's your answer. I know that was confusing. I'm sorry. I'm doing the best I can here. All right, this last one, they're talking about temperature over time. So instead of height, the y-axis is going to be temperature now. So basically, x is still time. And they say the first thing I see is 35 minutes after they start timing. So 35 minutes after they start timing, its temperature reaches a high of 120 degrees. Up here, 120. 20 minutes after that, 20 minutes, it reaches its low of 104 right here. So the period's not 20 here. That's only half the period. The period is 40. So if you go 2 pi over b equals 40, cross multiply, divide and reduce. You get pi over 20 as your b value. All right, so let's draw the graph. It looks something like this. There would be another high 20 minutes later, so 75. Go get your midline, so that's 112. And let's go ahead and write the equation. So f of x equals, Your A value is your distance off the midline, 8. This is a positive cosine function. So for example, if I had started low and then been given the high, like this, it would have been a negative 8 cosine. Just keep that in mind. All right, but anyways, this one's a positive cosine. Your B value was pi over 20. The start was at 35. And your midline is 112. There's my equation. What was the temperature when they first started timing? So that's when there was an X value of 0. So you just plug in X value equal to 0 right here. And then you go solve that, just punch it in the calculator. You'll get 117.657, so 66 really degrees. And I'm going to actually change that back to 657. I think they like 3 decimal places on these. Right. Find the first 3 times after they started timing at which the temperature was 114 degrees. So what you're going to do is you're going to plug in a Y value of 114. And you're going to solve for your X value. And so when you do this, you're going to get 43.4, like here. 43.4. All right. Now, my graph is a little misleading, so I'm going to fix it just a little bit. I need more space. Okay. The reason I redrew this is because there's still more sections of line over here. Like this. And so basically there's a, that still wasn't very good. I'm sorry. Let me do this one more time. Okay, like that. That's better. All right. We got 43.4, but there's also these other 2 locations because they want 3 times when the temperature was that. So we knew one of them, 43.4, and we need to find those other 2 green dots. I'm trying to move the screen to get some more room to work. Okay, here we go. So one of our answers is 43.4. Well, you can get one of these other dots by doing 43.4 minus 1 full period. Remember, the period was 40. So you do 43.4 minus 1 full period is 3.4. That's another one of my answers. So 43.4, 3.4. That's this dot right here. That leaves one more. This one. Now, what you need to do is you need to think this right here is at 15, this low. Because it's 1 full period being 40, right? I just did 55 minus 40. So this distance we know because we know this location is at 3.4. So you do 15 minus that 3.4, which is 11.6. That's this distance right here. So you go that way, that much off of 15 this time to get to this dot. So 15 plus 11.6 is 26.6. That's my other location. I know that was super confusing. I'm sorry. You need to kind of just get the hang of if you know If you know red's distance, then you know blue's distance to the same height. That's what I'm trying to tell you. All right, I know this wasn't my best video. I apologize. Sinusoidals are hard. They're complicated. You really have to draw a good picture. And then you really have to be careful writing your equation. Make sure you do the right B values, solving B correctly. Once you have all that, you still have to plug stuff in, get those answers. And if they give you a Y value and make you solve for the X value, really take your time. This is how you solve them. I worked one out for you, so I don't know. Hope this video helped.